Hello and welcome to this video on quantitative reasoning. This is part 2 of 2 videos on Venn diagrams with focusing mostly on 2 sets. It's kind of our introduction to Venn diagrams. So, as I said in video 1, Venn diagrams are basically the graph of sets. You know, when you learned math early on, you learned a number line. That was a form of graphing just one number, or when you were dealing with a single variable, and then you learned how to graph in the XY coordinate plane for algebra. In statistics, we have lots of ways to represent our data and our graph and our conclusions, and we have frequency distributions and things like that. In sets, we have graphs called Venn diagrams. It's a picture that shows you how the sets are related and organized. So, these were invented by a man named John Venn. In a Venn diagram, each set under consideration is represented by a circle, usually drawn inside of a containing box, which represents the universal set. That's that rectangular gray area we've been talking about and dealing with. Any overlapping areas are used to include all elements common to the overlapping sets, and non-overlapping areas are reserved for elements belonging only to the set containing. So if I have something that's an A, so if I have 2 circles, this one's set A, and there's an overlap, and this one's set B, and I have the number 2 is in set A but not in set B, I would write the number 2 here. If the number 5 was in set B but not in set A, I'd write the number 5 here. If the number 4 showed up in both sets, it would have to be written here in the overlap. It shows it's in A and it's in B. That's what that translation of these words means. So we're asked to draw a Venn diagram for the sets A is 3, 8, 13, B is 3, 6, 12, 15, and the universal set is 3, 6, 8, 12, 13, 15. When we are done drawing our Venn diagram, each of these elements will appear once and only once, and they will appear in the correct position, either in set A, in set B, and the overlap between them, or outside of the sets on the paper, indicating they're in the universal set, but not in either one of these sets. The first thing you have to do is find the intersection. So what we notice is the number 3 belongs to both. That's the only number in both sets. It's easiest to find the intersection first and then to do the rest of the drawing. So we have 3, 8, hopefully this will, okay. So there's your 3. It's in the intersection. That's the one you do first. And I can see by looking at this circle, if I go back to the last slide, set A should be the set containing 3, 8, and 13, because they're all in this blue circle. So that's how you would read a Venn diagram. And I go back, and I see, yes, A has 3, 8, 13. B has 3, 6, 12, 15. Let me see if that's right. 3, 6, 12, 15 for B. We're over here. And 3 was in both of them. And I should find the entire universal set, 3, 6, 8, 12, 13, 15, is written on this paper. 3, 6, 8, 12, 13, 15 is there. Now, every element showed up once and only once. If I change my universal set to add the number 17, let me show you where that would go. 17 is not in A, and it's also not in B. So what you would do is the 17 would just be written out here somewhere outside of the 2 circles, but it would have to appear in your diagram still. So this was the draw a Venn diagram representing A equals 1, 3, 4, 5, 10, B equals 3, 5, 10, 12, and the universal set is 1. This is another one where they give you a universal set and everything shows up in either A or B. So first I identify the intersection. It looks like I have a 3 and a 5, a 3 and a 5. Oh, and I have a 10 also. 3, 5, and 10. So those get written here. 3, 5, and 10. This is the intersection. Then I look at set A. I've already written the 3, I've already written the 5, I've already written the 10, so I have a 1 and a 4 left, so I write those in set A. In set B, I just have a 12 left, so I write that. And again, if my universal set had the number, let's say it had one more, it had a 15 in it, that 15 would have gotten written out here or down here, just somewhere outside of the 2 circles, but inside the rectangle. And this is telling you how they find 3, 5, and 10 first. All right, draw a Venn diagram that models these sets. 1, 3, 5, 7, 9, 2, 4, 5, 7, 10. They did not give me a universal set, so it's technically not a complete problem, but again, you identify what's in the intersection. I have a 5 and a 7 that shows up in both sets. So then I decide I have to write the 5 and the 7 in the middle. And then you go up to write set A, and you say, all right, I've already written the 5, I've already written the 7. I have to write a 1, I have to write a 3, I have to write a 9. Okay, in set B, I've already written the 5 and I've already written the 7. I don't write them twice. Everything shows up once. 2, 4, 10. I write that in set B. Now, if my universal set had been the set of numbers from 1 to 10, I have a 1, a 2, a 3, a 4, a 5. I'd be missing a 6 and an 8. They would have to be out here if my universal set had been 1 through 10. They didn't give me a universal set for this problem, so we just assume they only want us to draw what they asked for. Okay, so this explains 5 and 7 are in both A and B. Always find the intersection first. And then, so I find the intersection, I put it where it belongs. I cross it out of A, and then I write the rest of what's in A. And you could also, if you were the numbers all the way through 10, like I said, write out the universal set. And as soon as you write a number down on the graph somewhere, on the diagram, what you would do, okay, I already wrote down the 5 and the 7. I'm not going to have to put that in the end. Then I check set A, 1, 3, 9. I write down the 1, I write down the 3, write down the 9. All right, I've taken care of those out of my universal set. Then I check set B, the rest of B. Okay, the 5 and the 7 are there already. 2, 4, 10. I write the 2, the 4, the 10. Cross them out of my universal set. And I can see I have 2 elements of the universal set left that were not already written down, so I have to write them down out here. That is the way you would proceed to make a 2-set Venn diagram. All right, hope to see you in class and hope this is helpful in answering your questions.